activities. Scientists learned that as continental and oceanic crusts move, they can form geologic events such as earthquakes, volcanoes, and mountain ranges. Have you seen a world map before? Definitely yes, you have seen one. Take a look at this one. What can you say about the eastern border of South America and the western part of Africa? You have probably noticed that the eastern border of South America and the western part of Africa seem to fit together like a big jigsaw puzzle. If you're thinking the same answer, then you are thinking like Alfred Wegener, who was a German polar researcher, geophysicist, and meteorologist. He is remembered as the originator of the continental drift theory by hypothesizing in 1912 that the continents are slowly drifting around the Earth and is once a large landmass called Pangaea, a Greek word which means all Earth. Take a look at these figures. What do you see? These figures show the evolution of the supercontinent Pangaea to the present-day distribution of continents. Can you say that continents are drifting? Wegener's curiosity about the idea of drifting continents started when he noticed the edges of South America and Africa in a world map could be fitted like a jigsaw puzzle. To better understand this, let's explore the evidence that Alfred Wegener gathered. What do you see? This shows similar rock assemblages across different continents. Alfred Wegener collected diverse pieces of evidence to support his theory, including geological fit and fossil evidence. It is important to know that the following specific fossil evidence was not brought up by Wegener to support his theory. Wegener did not collect the fossils, but he called attention to the idea of using these scientific documents stating there were fossils of species present in separate continents in order to support his claim. Geological fit evidence is the matching of large-scale geological features on different continents. It has been noted that the coastlines of South America and West Africa seem to match up. However, more particularly, the rock terrains of separate continents confirm as well. Examples include the Appalachian Mountains of eastern North America, linked with the Scottish Highlands, and the familiar rock of strata of the Cairo system of South Africa, matched correctly with the Santa Catarina system in Brazil, and Brazil and Ghana mountain ranges agreeing over the Atlantic Ocean. Glaciers carve rocks and leave marks as they move. In this evidence, scientists can determine the direction of movement of each continent. In addition, the existence of coal deposits in Antarctica suggested that it has once located near in the region of the Earth where the climate is enough to support complex life forms such as plants and tall trees. Focus your attention to this figure. Can you notice the direction of the movements of the continents? The direction of the movement of the continents is indicated by the arrows during Pangaea time. This time, look at this map. What does it show? It shows how Alfred Wegener mapped out the distribution of the four Permian and Triassic fossil groups and used it as biogeographic evidence for continental drift and land bridging. Wonder Warriors, how are you so far? Don't forget to take note of the important details on a piece of paper. Remember, by taking notes, you can easily remember our lessons. Got it? Very good! Let's proceed! And now, I would like you to focus your attention to these four illustrations. Can you name these organisms? Did you know that they are considered evidence of the movement of the continents? Let's get to know them one by one. Let's have the first illustration. This is a modern-day representation of the Mesosaurus. Did you know that the Mesosaurus is known to have been a type of reptile, similar to the modern crocodile? Mesosaurus, like the modern ones, propelled itself through the water with its long hind legs and limber tail. It lived during the early Permian period, that's around 286 to 258 million years ago, and its remains are found solely in South Africa and eastern South America. Now, if the continents were still in their present positions, there is no possibility that the Mesosaurus would have the capability to swim across such a large body of ocean like the Atlantic because it was a coastal animal. How about the second illustration? Can you name this mammal-like reptile? This is a modern-day representation of the Cynognathus. The now extinct Cynognathus was a mammal-like reptile. Roaming the terrains during the Triassic period, that's around 250 to 240 million years ago, the Cynognathus was as large as a modern wolf. Its fossils are found only in South Africa and South America. As a dominant land species, the Cynognathus would have been capable of migrating across the Atlantic. Let's have the third one. This is a modern-day representation of the Lystrosaurus. The Lystrosaurus, which translates to shovel reptile, is thought to have been a herbivore with a snout built like a pig. Lystrosaurus fossils are only found in Antarctica, India, and South Africa. Similar to the land-dwelling Cynognathus, the Lystrosaurus would not have had the swimming capability to traverse any ocean. And finally, the modern-day representation of Glossopteris. Possibly the most important fossil evidence found in the plant is Glossopteris. The Glossopteris fossil is found in Australia, Antarctica, India, South Africa, and South America, all the southern continents. Glossopteris seed is known to be large and bulky, and possibly could have drifted or flown across the oceans to a separate continent. Therefore, the continents must have been joined at least one point in time in order to maintain the Glossopteris wide range across the southern continents. To wrap it up, this illustration will show you the fossil locations of the Mesosaurus, Cynognathus, Lystrosaurus, and Glossopteris spread across different continents. So there, you have just learned that Alfred Wegener's curiosity drives him to look for evidence that supports his continental drift theory that continents were once connected as a big landmass called Pangaea. The continental drift theory is being supported by the following evidence: continental fit, matching of rocks, fossils of ancient organisms, coal deposits in Antarctica, ancient climates, and glaciers carvings. And now,